Hello everyone, I am Abhishek Kumar Chaudhary, Senior Physics Lecturer, Sri Chaitanya Gosala. Today in the NEET revision series, we are going to do one topic, easy but very important for NEET, motion under gravity. It is part of kinematics, 1D motion. Motion under gravity is also, you can say, a part of uniformly accelerated motion, but that also in vertical direction. Okay, motion under gravity. The name is very clear. We are going to discuss under gravity for any object whose mass is m, gravity applied by earth, the force applied by earth is mg. And when we are taking the object only as a system, earth is not part of it, only object is the system, then this mg is taken as external force acting on the object. Your gravity, your weight on you, my weight on me, these are the external forces which are not being applied by ourselves, that is being applied by the earth on us, right? If this is the force, what will be acceleration? Acceleration will be force by mass because it's a constant force. Why I am saying constant? I will elaborate that also. That is mg by m and that is equal to g. So when we talk about motion under gravity, the acceleration is equal to g, whose numerical value near Earth's surface, because that is the constant, you can say that is the limitation in this particular topic. We will take gravity near Earth's surface. We know that gravity might change with height, with depth, with rotation, but that is the part of gravitation. Here we will discuss it near Earth's surface and then it will be treated as constant. 9.8 meter per second square, almost equal to 10 meter per second square, that you have to take when it is given in the question, and sometimes in feet also it will be there. So that will be 32 feet per second square, approximately in feet. Sometimes that mistake can happen. Your distance is given in feet and you are using g in meter, so that answer will not match over there. Okay. So it is what kind of motion? First point that we have to revise is uniformly accelerated motion. Okay, near Earth's surface. Now there are very basic concepts in this. It's a very easy topic. The basic concept that we need to revise. First one, if I will tell, that is the sign. If your sign is not proper, most of the questions you will get right answer with opposite sign. And if in options, both signs are there, that can lead to negative marking. So sign is one of the very important factor to think about when we are discussing motion under gravity. What is sign? In sign, some you will discuss with your friend or you will think some questions. So one concept you will develop is sometimes G is negative, sometimes G is positive. But the point is, G is only one, no. G is the only one that gravity is, the earth is applying on us. So when only one G is there, then it is not fair of saying ki plus G and minus G. That way it appears ki G is 2. There is no 2G, only one gravity is there. When only one gravity is there, it means sign is not actually the characteristic of G. It is characteristic of vector quantity, and every vector quantity has a direction. Every vector has a direction, and according to that direction, according to convention, sometimes according to XY axis, sometimes according to a hypothetical system that is given in question, means direction is solely on us, how we take it. Gravity comes with only G, which is vertically downward. Now suppose I will take a general axis. I'm not talking about any hypothetical thing that is given in the question. So this is Y axis, positive. This is y-axis negative, this is x-axis positive, and this is x-axis negative. If this is origin, every motion has it. If this is origin, from where we are measuring with respect to what we are measuring the motion, so where will be G? Downward, no. And according to this much convention, G being downward is towards negative y-axis. Negative y-axis, so I will take G as minus sign. That is not that G is negative. That acceleration vector is along negative y-axis. So y-axis is negative, and since G is towards y-axis, the direction is negative. It doesn't mean that G is less than 0. It just means this conventionally negative direction is indicating G. According to that, G can never be up, no? G can never be up, so G can never be positive. So always do one thing for question solving. Don't specifically assign direction to G. Always give direction to all vector quantities in the question according to axis. I'm showing you one example. Suppose this is some height, and from here I'm throwing some particle up, right? That is the origin. Origin I'm not taking at ground. If you can see a question, that type of question where particle is object is projected from some height. I'm projecting from here. When I'm projecting from here, and that is my origin, upward axis is positive, downward axis is negative. Particle will go up, and obviously after coming to momentary rest, it will come down also. So it is coming down also. Then in vertical direction, along y-axis, only displacement from initial to final point is h. I'm not talking about total displacement. That could be here also. Only y-axis, it's just going up and coming down, vertical direction. That displacement, you have to check it is vector quantity, so I will take direction for displacement also, and that is coming along negative y-axis, so I will write minus h. Velocity, positive y-axis, what I am taking, plus u, and g minus. That way we are assigning direction to all vectors, not only g. That is always you have to keep in mind. And then if I am writing s equal to ut plus half at square, then s equal to minus h, u equal to plus u, and a equal to minus g t square. This is the way of writing the equation, and that equation we have to solve to find any unknown that question is given us or asking us. So that sign convention you have to take into account. Always keep in mind there is no sign for G only. Sign is always for all the vectors according to axis or according to any convention that is given in the question. Not given, then general convention according to axis we have to take. Second, what I will suggest all of you when you are going under gravity and revising this topic, always bifurcate it into two parts. One is up motion, one is fall. And try to revise gravity according to upward projected and according to fall. We will see few questions, past year also, general question also. Up and fall, like this was up. Some other question where you are releasing a ball or falling it from some height. In fall, there is one thing that is very, very important to revise. In general, when fall is coming, we can tempt for taking initial velocity equal to 0. But that is not always true. You have to understand the initial velocity during fall. That is the most important part of the question. Initial velocity means what? Initial velocity means when your motion has started, just before that, motion has started, starting velocity is not initial velocity. It's the velocity before the start. And before the start, if I am dropping a coin from a bus, dropping a coin in a moving lift, dropping something from some moving like aeroplane or some moving frame, then before I have dropped, that pebble, that particle, that coin was in a moving frame. It means when I'm dropping, initial velocity is not 0. Initial velocity is velocity of that surface, that frame from where we have dropped it. So initial velocity from a building is at rest. Initial velocity is 0. But from a moving bus, if I'm dropping something, so initial velocity, both magnitude and direction of initial velocity will be velocity of that bus. That we have to understand here. The initial velocity of fall is not 0, not equal to 0 always, may or may not be 0. Rather, it is equal to velocity of surface that you have to take. So these are the few points we have to keep in mind. First, sign convention, that is for all the vector, not only for G. And then up and fall, we will memorize our formula, right? Upward motion under gravity and fall motion under gravity. Like rebounding is what, or tap problem is what, or time of fall is what. Like this fall and up, they are two different categories that we have to revise. During fall, one basic misconception or mistake we can do that we don't have to, that during fall, initial velocity is not always zero. It is equal to the velocity of that surface, that frame from where we have dropped it. Okay. Having said this, all basics about this, now we will see few questions, some previous year questions. What kind of question NEET has asked it, to just get a basic idea. Okay. Come to the questions. Question number 1. See this question. In this question, a man throws balls with the same speed, that is 1.2. Focus on. Vertically upward, as I told you, there is a upward motion or fall motion, that is vertically upward motion. One after the other at an interval of 2 seconds. What should be the speed of the throw so that more than 2 balls are, see, this is the key of the question. More than 2 balls are in the sky at any time. More than 2 balls. Try to understand in this question, you are not throwing 2 balls. You have to keep 2 balls in the air. See the first line, man throws balls. It is number of balls not given, ki how many balls man can throw 3 balls, 5 balls. 2 balls has to be in air. Number of balls could be anything. Got it? So here man throws balls with same speed. Now understand, this time is given how much? Interval of 2 seconds. Time interval of 2 seconds. One ball has been thrown up with some speed u. It is going upward, and then after 2 seconds it has reached at some point 2 seconds, and then second ball is being thrown from here. Imagine ki 3 balls are there, and if you want to analyze with the answer. Suppose I am taking, one option is saying less than 19.6, second is saying 19.6, third is more than 19.6. So one thing we can do, take 19.6 as a reference initial velocity, that is equal to 19.6. If this is 19.6, then time of flight will be 2u by g, that is equal to 2 into 19.6 by 9.8, and that is equal to 4 seconds. Means in 4 seconds, it will go up and come down. According to our question, the interval is 2 seconds. It means in 2 seconds, the first ball is at the maximum height and the second ball you are throwing. Okay? Now, this ball is coming here. This ball is coming here in 4 seconds. Then it will be reaching here. That way only one ball is in air, because one ball has already touched the ground. Only one ball is in air if you are throwing with 19.6. Understand the question. 19.6 if I am throwing. So in 4 second time of flight, the first ball has reached the ground and only the one ball, the second ball, is in air. But if I am throwing more than 19.6, it means one ball is in air, one is somewhere in the midpoint, and the third ball is just up. So that way 2 balls will be in the air. So 19.6 we have taken the reference. At 19.6, one ball is in air. More than 19.6, the first ball back, the second ball midway somewhere, and the third ball is little up, it has been thrown. So 2 balls will be in air. So answer will be more than 19.6. Any velocity more than 19.6. That question is completely analysis question rather than a simple equation and putting the value, getting the answer. That's not here. So this way of question, this kind of question are very much there for negative marking. So analyze full. Don't carry it away with something here and don't hurry in writing these questions. Okay. See the next one. Ball is thrown vertically upward. It has a speed of 10 meters per second when it has reached 1/2 of its maximum height. This is again, see the bifurcation of motion up or motion fall. 2 category of motion under gravity. So ball is thrown vertically up. Ball is thrown with vertically up. It has a speed of 10 meters per second. That is also given. Speed of 10 meters per second. If speed is of 10 meters per second, it has, when it has reached 1/2 of its maximum height. Okay. So that this speed is basically at a height of h by 2. Okay. Means initial speed is something that we have to find u. And then question is asking how high. How high means question is asking me maximum height. Very simple, one formula. Question is this, just the analysis. What is the formula of maximum height in motion under gravity? U square by 2g. So if we can get u, we can get h max. And u, this is 1D motion, v square equal to u square plus twice as. Now v is to given. See the direction also upward. Square 100. U is required, u square. Plus a is downward. A is g. G is downward. Downward sign is minus. Don't do this mistake of not considering the sign in motion under gravity, kids. You have to take motion under gravity sign of every vector. That should be the routine solving. Like v is upward positive, but square anyhow it will come positive. U is unknown. I am not taking the sign because it is unknown. It will come with sign. I don't know the sign, but upward is projection, so I can put plus sign. Even after that also it is a square. So any sign will be there, plus or minus, u square will be positive. A sign is minus g because that is downward. What axis is downward? Minus y. And displacement is upward. Displacement is h by 2. That is h by 2. Plus sign I have taken. From here, if I am solving 2 cancel. That is u square minus g. And do we know what is h? Maximum height is how much? It is u square by 2g. G cancelled. U square minus u square by 2. Basically, we are getting u square by 2 is equal to u square by 2. U square by 2 is equal to 100. But we want u square by 2 is given. We want u square by g. So what we will do here? Divide by g. We are dividing by g. G is 10. What we are getting? 10 meter. And 10 meter, that is u square by 2g, is the maximum height. Okay, solving C once what we did. Question is asking upward, that is the bifurcation first, not fall motion, it is upward motion. It is uniformly accelerated motion. So uniformly accelerated, what are the equations? Equations are S equal to ut plus half at square, v equal to u plus at. Basic equation, v square equal to u square plus twice as. Out of these uniformly accelerated motion, some formula we have to use. In the given question, initial velocity, final velocity and height means displacement relation with initial final. A is always known to us, that is g in motion under gravity. So I picked this formula. From this formula, I calculated u square by 2 value and we wanted maximum height, that is u square by 2g divided by g both the side, we got 10 meter. That is one formula question, motion under gravity. So always go with that, upward, downward, whatever is there, motion equations will always be 1D equations. These are the some thought always keep running in your mind. Got it? See the next one. Now reading this question. Ball is dropped. Now this question is under the category of drop. Every question, kids, you will see that way. Either upward or drop. Upward fall. Upward projected fall. But whenever it is fall, drop, what we discussed in the primary session, the first thing we discussed, in drop, in fall, the initial velocity is the key thing. From where it is dropped, that surface velocity is initial velocity. So that will be keep in mind. It is dropped from a high rise platform at t equal to 0. Starting from rest, that has to be given because platform is at rest. Starting from rest means initial velocity of drop is 0. If the same question says that the platform is rising up with some velocity, then dropping initial velocity will also be upward. So that is the key thing in every drop question we should take care of. After 6 seconds, another ball is thrown downward. Okay, after 6 seconds, another ball. Discuss about the first ball. First ball is the alone ball which is moving for 6 seconds. Second ball is to coming after that, no. So first is for 6 seconds. In 6 seconds, initial velocity is equal to 0 and it is falling for 6 seconds. When it is falling for 6 seconds, how much distance it will fall? It will fall half g t square. That is equal to half into, as I told you, whatever g is given in the question that we will take, otherwise 9.8. So that is g, and t square is 6 square, 6 seconds, that is 36. Okay, half g t square, that is equal to 18, and it is 180 meter. 180 meter, the first ball has fallen alone. Then second ball comes into picture. Now another ball is thrown downward from the same platform with a speed v. Now this is your ball number 2, which is going down with a speed v, and it is going down with a speed v. Two ball meet at 18 seconds. Please try to understand here, this all time is given with respect to that reference. T equal to 0, then t equal to 6, first ball is moving. Then t equal to 18, means all this time are measured from t equal to 0. What I want to say, second ball is falling after 6 seconds, means second ball is only left 12 seconds to meet to the first ball. T0, 6 seconds first ball has moved. Now second ball is released, but both are meeting at 18 seconds. So first has moved for 18, but second has moved for 12 seconds only. They are meeting for 18 seconds. We can use this for relative, or we can use one thing. In 18 seconds, what is the height fall by the first ball? Half into g into t square, that is 18 square, or 324 we can use, or 18 into 18, right? That is the height in 18 seconds, because first ball is so continuously moving, no? It is not stopping somewhere. So we can use this, that is 324 divided by 2 into 10. This much height first ball has fallen. So second ball want to meet this. So second ball also have to fall same height, no? But second ball has only 12 seconds to do that. 12 seconds because it has started its journey after 6 seconds. So for H1, that same height has to be of H2. Same height has to be of H2. That we have to understand. And this I was doing for relative, but if I am not taking relative here, then we can do one thing. Understand that sequence of the question. Your first ball has fallen for 18 seconds, but second ball is only falling for 12 seconds. So that is equal to 324 by 2 into 10. That is the height fallen by second ball also, as it wants to meet the first ball with velocity v. Time is 12 plus half gt square. Now you might ask me why you are taking plus g here, because velocity is also downward. That will be minus. This will be minus, g will be minus, and that height is also downward. Downward is negative y. This will also be minus. Minus h equal to minus vt minus half gt square. We will always keep in mind all vector sign we have to take for proper equation forming, and after that you will solve for t. T is given here 12. T is 12. T is equal to 12. You will solve for v, and that you will get 75. This is the answer. So understand the key of the question. First ball has been dropped for 6 seconds, but it is meeting with the second ball after 18 seconds, means that 6 seconds is for the second ball. It is not for the first ball. First ball is so continuously dropping for 18 seconds. Now second ball started motion after 6 seconds. After 6, but still it is meeting with the first. It means in 12 seconds, the second ball has covered the same height that the first ball has dropped in 18 seconds. But second ball has a non-zero initial velocity, that is this, with 12 seconds, and this is for first ball. H1 equal to H2. From here we have to find V. This is also drop motion, single equation question, if you will see. So what we are getting out of these all question in motion under gravity that NEET has asked, the first part we are deciding it is upward or it is fall. And then sign convention is something that can ditch you. If you are little casual with the sign convention, questions will be different answer, and most of the time those answers will there in 4 options. That will give you negative marking. Don't take sign convention casual. Okay. So that is your this question solving. Going to the next one. See this question. AIPMT screening 11. There is a boy standing at the top of a tower of 20-meter height, drops a stone. We picked our first fall question, first category question, either upward or fall. So in this question, motion under gravity is drop. Again, in drop, what becomes very important? Drop means initially the frame is what? Surface is what? From where you're dropping it. So see, a boy standing at the top of a tower. So tower to cannot move, no? Tower is a static thing. So it means the boy is also at rest and it is dropping the stone. So here I will take initial velocity 0, not because it is always 0 in the drop, just because it is being dropped from the height from the tower, and tower is not a moving frame. Assuming g equal to 10, drop question, velocity with which it hits the ground. Simple question. Now, what is given? Height given. What is required? Velocity. Equation we are damn sure we have to use 1D equations. So when I am using 1D equation here, what I will use? V square equal to U square plus twice AS. And then one thing we have to take care of, that is the sign convention. We will not be casual as we have discussed already. V question is asking us, that is simply unknown. V square. U is equal to what? 0. Where is G acting when you're dropping it? Downward. For conventional axis, downward is negative. So it will be minus. Displacement is also covered downward. That is equal to height, and downward axis is minus y. So it has to be minus as well. So you will write 2 minus G minus H. And from here, V will be equal to root 2GH. 2G question is asking us to take as 10. Height is also given as 20. So that will be equal to 400 under root, that is 20 meter per second. So that will be answer 20 meter per second. Understood this? So you will see in most of the question, 1D equation will be used, sign convention will be used, and drop or projected up. Drop or projected up. In drop, just little thing we have to think, ki initial velocity is what? There we cannot be blindly taking it 0 all the time. Most of the question it will be 0, but not always. So this should be a habit of checking. Okay. Next question. If a ball is thrown vertically upward. Now we are getting some keys here how to discuss question. Ball is thrown vertically upward. So this is not a fall question. This is upward. And at 40 meter per second. Its velocity after 2 seconds, that is time required, is velocity thrown vertically upward, initial velocity given. It is thrown up. That is your origin. Thrown up, initial velocity is given 40 meter per second. Its velocity after 2 seconds. Velocity after 2 seconds, Vt relation, V equal to U plus At. And after writing equation, immediately after writing equation, sign convention has to be taken care of. So V, question is asking you V, unknown, write V as it is. Conventional axis, this is positive Y, this is negative Y. U is going up, plus 40, plus A. A in motion under gravity is a known quantity, that is downward G. Downward is what axis gets? Minus G. Minus G, that is 10. How much time? Which is always positive. Time is 2. So that is 40 minus 20. That will be 20 meter per second. So we will see the option 20 meter per second. Again in this question, up and down. First equation, what to use out of the given uniformly accelerated equations. Second, And after equation, proper sign convention. This is going to give you a very concrete idea about motion under gravity. Next question. Velocity time curve means question is related to graph. VT graph for a body projected vertically upward. First point of discussion, upward motion, motion under gravity. What equation we want? Second, VT. And VT equation we have to write with sign convention. That is the three category of question solving of motion under gravity. Okay, but one more thing I will introduce here, graph. You know, when question is related to graph, there are three types of question we can expect in NEET. One is plotting of graph. Second is information from graph. One graph is given and some information based on that question is asking us. The third one is the conversion of graph. One graph is there, another graph is required. So this question is related to the first category, plotting of graph. And plotting of graph, what kind of curve, what kind of graph, that is always and always one should practice according to equations. That is the only thing. If you are plotting graph according to it is increasing, it is decreasing, and that will always be fruitful. Always make a habit. Graph you want, always write the equation and on that basis try to pick it up. So body is going up. It is going up with velocity u, let's say. And g is downward. So that is the negative y and that is the positive y. These are the two axes. Now I want to write Vt. Equation is what in Vt? Vt equation is V equal to u plus At. And in motion under gravity, directly we will never use equation values. We have to consider sign. So when I am considering sign, what is V? V though I have unknown here, Vt. U is upward, I will put positive sign to it, plus U. A is downward, minus Gt. The first physical quantity is for y-axis, second physical quantity is for x-axis, dependent, independent. X-axis is independent, that is dependent. So V is on y, T is on x, that is a constant intercept minus m. So what equation I got? V power 1, T power 1. When both axes y and x power 1, graph has to be straight line, linear. And linear equation may we are getting negative slope minus mx and positive intercept. So graph will be that way, negative slope and positive intercept. Graph will be like this, negative slope, positive intercept. But this is not asking the proper graph. One NEET question have been like that also. The proper graph they have asked. Here they are only asking the pattern. So we will directly write a straight line because Vt equation is a straight line. So no further work is done. But if question is asking the proper graph, then a straight line, all four options could be straight line where we will go. So that's why when proper graph is required, write proper sign and according to slope and intercept, you have to pick the graph. So that is the proper graph and that is the pattern of the curve. So what is the summary for this question? When curve question comes, always decide the curve according to equation, not according to any decrease, increase and any other analytical discussion. Always curve through the equations. Moving to the next question. Now before I will see the question, let's summarize the pattern. Upward or downward? Equation, sign. This is the basic pattern of every motion under gravity questions. That I hope up to now you have picked it up. In this question also, AIMS 2005 question, let's have a look. When a ball is thrown up. So first thing we have picked it up. It is not the fall question, it is the thrown up question projected up. Vertically with velocity v0. Okay, up to here you are throwing something up with velocity v0. It reaches a maximum height of h. It reaches a maximum height of h that has to be equal to v0 square by 2g. That is the maximum height. If one wishes to triple the maximum height, now your wish is to have h dash that is equal to 3h that is equal to 3v0 square by 2g that you want to have now. maximum height you have tripled, then the ball should be thrown. Then you want the initial velocity, let's say it is u, and u square by 2g. Cancelled. What is u here? Root 3 v naught. Why it is coming positive? Because you're throwing up. When you're throwing up, so u has to be positive according to normal convention, because upward is positive y-axis. Moreover, this question is asking you see velocity. It is not asking you speed. So question might give you option now on the basis of sign also, because velocity is a vector quantity. It can have plus sign also, minus sign also. When it is speed asking, then always plus magnitude. But if velocity asking, here all options are positive, so it's very easy to pick it up. But that question can become a confusing one when question is giving one option as root 3 v naught and second is minus root 3 v naught, because it is asking velocity can have both the direction. Since it is projecting up, there is nothing there to think about projecting up. Conventionally, it is positive y, and that has to be positive sign. That was an easy question, AIMS 2005 question. Moving up to the next one. This question we were talking about, the same question we have solved. Also, AIMS has asked it in 2007. Particle is thrown above, then correct VT graph. Now the question is asking the graph pattern, not just the curve name. In this, VT equation for motion under gravity, which is uniformly accelerated, V power is 1, T power is 1, graph has to be straight line. These two are completely ruled out. Only these two are there. Moreover, VT, A in upward projection, already we have solved. For upward projection, A is negative, U is positive. So it is coming U minus GT, and U minus GT is minus mx plus c. As we have discussed, graphical pattern we will pick through equation. So this is the graph. Already we have drawn also. That I was telling you, sometimes question will ask you the precise graph. It's a very easy option because two are already curved. If all four are straight line, then you have to be very specific. And that specification might come by taking the proper sign. So sign convention is something that you have always practiced with full accuracy as far as motion under gravity is concerned. Got kids? I hope you are getting up the motion under gravity, how to solve questions, how to think, how to analyze. Okay, to solve more, see on the next question, line by line read, think sign, thin equation and solve. Two particles, okay, projected vertically up, that is the first key thing that we always discuss. Two particles are projected up with the same velocity on two different planets. Acceleration due to gravity is at g1 and g2, okay, respectively. So we have two particles at two different planets with different acceleration due to gravity, but projection at both the planets are vertically up. If they fall back to their initial point of projection after lapse of time t1 and t2. Now we are throwing up and it is coming down. This time is called time of flight. So this question is related to time of flight. Do one thing, for upward projection, prepare a list of some basic formula. 1D equation are to there to be used. Time of flight 2u by g, maximum height u square by 2g. This kind of at a certain height, 2 time that h equal to half g t1 t2. This kind of formula for upward and downward, prepare for your revision of this topic for NEET 2024. See, so these are, have we picked that these are time of flight, and time of flight is t1 and t2. Then they are asking, see, if they fall back to their initial points of projection after lapse of time, so t1 will be equal to 2u by g1 and t2 equal to 2u by g2. We have to pick in this question, that is the question solving point, same velocity. You can see I have taken u as same, both where u is same velocity. Then from here u will be, 2u will be g1 t1, and from here 2u will be g2 t2. It means whatever is g1 t1 on one planet, that is g2 t2 on other planet. That should be the option we will take. G1 T1 equal to G2 T2. That second option is the correct option. So basically all the questions are formula based, sign convention based, and two categories, either upward or downward. Okay. I hope you got this question. See the next one. Again, we will use our basic understanding in this question. What we have understand. Okay, we have to predict up or down, then equation, and then sign. If sign is required there. Sign is generally always required, but sometimes it is so obvious that we don't need to pick up the sign. But I would suggest students that don't be casual with the sign, rather use in every question so that you will be more habitual of using it. Two balls are dropped. So first category to we have picked, dropped from same height, okay, dropping from the same height at two different places A and B, where the acceleration due to gravity are Ga and Gb. Acceleration due to gravity are G and Gb. See, you are dropping it. Height is same, h. This is the place, name it A. This is again the same height. This is another place. Let's name it B. And it are being dropped. What we have discussed for dropping, always we will check dropping is from static surface or moving surface, because initial velocity will be decided according to that. So they are dropped from the same height. No surface is given. So I will take initial velocity 0, assuming that it is a static surface, some building, some tower, and like that. Okay, here G is Ga, here G is Gb. Okay. The body at B takes t second less to reach ground. It means question says that Ta minus Tb is equal to T. B takes t second less. A takes t second more. That is that obvious. What is Ta Tb? Can I write under root 2h by Ga? Again, this is the time of fall in drop where initial velocity is 0. If initial velocity is not 0, that formula will not be used. Minus root 2h by Gb, that is equal to T. That question has given, I have only put the formula into it. And then question says, body B takes t second less and strikes the ground with a velocity greater than at A by V. Means obvious hai na, if its time is less, its velocity is more is there, like in more acceleration will be there. So Vb minus Va, that according to question is given as V. What I need to do, I have to put sign. If initial velocity is 0, Vv will be under root 2Ga, 2Gb is there, h minus under root 2Ga into h, and that is equal to V. So V and T indicatively, empirically given in the question. What we were doing, we have done just we will put the value formula into that, and then question is asking at last what is V by T. So we have to solve for V by T, where already we have the value of V and T. What is V? Under root 2h you can take common. So it will be root Gb minus root Ga. And then you can divide by T. That also have been calculated. If you can see, the root 2h can be taken common here also. So when we are taking root 2h common in T as well, what we are getting there as 1 by root Ga minus 1 by root Gb. Now only solving is required here. Here I will take LCM. So it will be Gb minus Ga divided by root Gb minus root Ga divided by root Ga Gb. That two being same will be cancelled. This will go in numerator. So I will go with root Ga Gb. That will be the answer. So again, this question, when first you will read, it looks like something difficult question, but it is nothing difficult. Just comparison of A and B given. Formula we have to put, ratio we have to take, and we are done with the question. Okay, look at this question. This kind of question, see, motion under gravity overall is a very easy topic. Formula based, convention based. So whenever gravity questions are coming, you practice that way, fall, upward, formula, equation, and make up your mind that this topic question I have to attempt in it and I will do it right, because it is one of the easiest topic. But having said that, This is also can cause silly mistakes for signs, silly mistakes for formula using. So that has to be taken care of. Say this question. One way of solving we have developed. We will do it quick. A ball falls freely. Fall, dropping question. From a height h, no surface given, u equal to 0. Average velocity when it reaches earth. Average velocity in any motion is displacement upon time. Let's say it is falling, it is given also h. So displacement of fall will be h and time of fall will be under root 2h by g. You got your answer. Time of fall will be root 2h by g. Velocity when it reaches average velocity. Not asking you direct. What is average velocity? Displacement by time. Body falls freely from height h. Average velocity when it reaches earth. When you can answer this conceptually, you can question one thing. What is the root 2gh? Root 2gh is the instantaneous velocity. From height h, the particle has come, strike the ground. At that particular point, velocity is root 2gh. But since it is an accelerated motion, g is acceleration, velocity will not be same everywhere. Initial velocity is 0, then after some time velocity is increasing. So at every instant velocity is different. So there are many velocities in the motion. So average velocity is different and instantaneous velocity is different. So final velocity root 2gs is that instantaneous one. You can't do that mistake, you are taking this. That will be the instantaneous velocity. When I am solving it, what it is becoming? That is under root h square by 2h by g. It is cancelled. This is under root gh by 2 and root gh by 2 is the second option. That question is very clearly telling you that motion under gravity, velocity is not uniform, acceleration is uniform. And velocity at every point will be different. So be very precise. If they are asking average velocity, use displacement by time. Don't use formula for instantaneous velocity. That can be a negative marking. Hope you got that concept. Moving to the next one. Two spheres of same size, one of mass 2 kg, another of mass 4 kg. Okay, you have two different spheres. Size is same, masses are different. Question will have something where mass can make a difference. That's why masses are different. Drop means motion under gravity. Simultaneously from top of Qutub Minar. Okay. AIMS 2006 question. Height is almost given 72. This question option when we see it is not a numerical question. Okay. Just quantity we have to discuss. When they are at 1 meter above the ground, my dear students, this is your ground here. 1 meter above, here are two particles. Okay. Now, they will have same what? Let's discuss what they will have same. Momentum, kinetic energy, potential energy and acceleration. See, what depends on mass? Momentum depends on mass into velocity. Kinetic energy depends on mass, half mv square. Potential energy, mgh. So here masses are same, but acceleration in fall is g. Acceleration does not depend on mass. So prima facie we can say in this question is some quantities depending on mass and masses are different. So that quantities could be different. If you want a precise discussion, here potential energy of first will be m1gh and second will be m2gh. That has to be different. Kinetic energy at this instant for first will be half m1 v squared is 2gh, h is same, and second will be half m2 2gh. That has to be equal to potential only. So these quantities are depending on mass, masses are different, so quantities are different, but quantity which is not depending on mass is g, that will have the same value. This question is based on a very simple concept, the acceleration due to gravity is independent of mass. It is not depending on how heavy or how light something is. It has a constant value, uniformly accelerated motion near the surface of Earth. That concept. So we can make a note out of it. Ki acceleration due to gravity does not depend on mass of a body. Having said that, do remember, it is only valid when we are not taking the drag. Drag questions are many applications, but up to now, recently NEET has not asked it. So we are only focusing on the uniform acceleration without drag. There, this concept is G does not depend on mass. Okay, this is the next question. Now, question solving strategy. If you are focusing 10-15 questions on each topic, by the real analysis of all the problems, it is a super revision going on. You will get to know each and every aspect of the question. Just looking at the question, reading the solution, that will sometimes create an illusion also. So whenever you discuss a topic, revise a topic, make a certain pattern of revision to what needs to revise. Like what we have made a pattern here. We have to take first the sign of G, which is very, very important. Then up and down motion, and then equation. Equation, the up and down equation sign. That is the basic pattern we have developed for discussing motion under gravity. In this question, look at this. Ball is dropped. You will see in every question that is given, either it drop or projected up, because their discussion, their analysis will be different altogether. Dropped vertically from a height D. Okay. Above the ground. First you are dropping it. Okay. It hits the ground and bounces up. It is hitting the ground and it is bouncing up. So in this particular, it's a rebounding question. There are two types of motion. One is drop, one is up. One is drop, one is up in the same question. Drop, up. But heights are not same. This is dA and here is d by 2. Neglecting subsequent motion and air resistance. We don't have to discuss any damn thing here, only gravity. Its velocity v varies with height. How many v we are having? 2, 1 downward, let's say v1, 1 upward, let's say v2. V is velocity. In some previous question we were discussing that velocity is a vector. Do proper sign convention of velocity vectors. Speed is okay, but velocity may we have to take. So what velocity? Downward. Downward conventionally we take negative. So we will take downward motion negative v. Negative means below origin. So below origin, this is not below origin. All are above origin. So this is completely ruled out because it is not dealing with the downward motion. Negative velocity is not there. Then I am writing the equation v square equal to 2gh. In this, power of v is 2. Power of v is 2 means a straight line we will not go. It is a parabolic one. So straight line we will ruled out. So this graph is gone. A straight line, both variables have to be power of 1. That has been ruled out. Now, this is again fourth, all negative not possible because downward is negative, upward is positive. So this is also ruled out. This is the answer. But how we find it? Exact pattern equation we did not write, just by the method of elimination we did. Now for proper concept, what we write? V square is 2gh, that is 2gd, and for this is v1 we have written. For upward motion, v2 square is equal to 2gd by 2. That has to be positive and that has to be negative. So you can say up to here is d, that is for downward motion, v is below origin, that is negative, and graph is parabolic. For upward motion, v is positive and that point is up to d by 2. And this is again parabolic but above origin. So this is motion upward and that is motion downward. So hence we can go on the option 1. This is how. Graphical questions, don't be very intense with it. Many students panic with the graph. Graphical questions are damn easy. Plotting is always according to equation. Plotting is according to equation. Sometimes what happens, you don't have to be very precise with the graph. Only by looking some questions, what shape, what above origin, below origin, origin crossing means direction change. Because above origin is plus, below origin is minus. Only one side means direction is not changing for vectors. These kind of concept you will do for graph, and practice graph questions if NEET is asking you, they will mostly be in one equation basis graph. That way you can discuss graph also. That was also very guess question. We can expect this kind of question in NEET. So that was motion under gravity. And now I hope that you have got this topic. So just a basic summary, motion under gravity is uniformly accelerated motion. In this uniformly accelerated motion, how we will revise? In our note, take a pen, notebook, write motion under gravity, upward motion, downward motion. Write formula, time of flight, maximum height, downward motion, time of flight and all. Having said that, all equation of uniformly accelerated motion do take care of sign. Unless given anything, your proper conventional sign convention is according to given axis. Upward is positive, downward is negative. That way in most of the question G comes negative, but do take sign of all the vector. Don't only be specific for G. Velocity, displacement, acceleration, all sign we have to take. Equation, sign, upward, downward, this way of practice do, and you will do all correct questions in NEET. God bless you. Bye-bye.